This is another case of evaluating the powers of sines and cosines with even exponents, but this time the even exponents are not the same anymore. So remember that in mathematics there are many different approaches in solving the problem. However, we always want to choose the shortest solution, the solution which would require lesser effort. So the shortest solution is always the most elegant solution. So in this case, we have sine x that is raised to a greater exponent 4. So we have two options here. We can either express sine of x to the power of 4 as a product of sine squared x and sine squared x, or we can express this as sine x or sine squared x quantity raised to the power of 2. So let's say we choose the second or the first option. So we write this as sine squared x, sine squared x, cosine squared x dx. So sine squared x, cosine squared x can be written using the laws of exponents. We can actually write that as sine of x, cosine of x, quantity squared dx. So that we have sine squared x, and sine x cosine x is actually equal to 1/2 sine of 2x, quantity squared dx. Next, we're going to rewrite sine squared x. We're going to reduce the exponent of sine squared x. Remember that if sine or cosine is raised to the power of 2 that is not integrable, we still have to reduce their exponents. Using the Pythagorean identity will not convert it into an integrable form. So we have to use the power reducing identity to convert that into an integrable form. So sine squared x is equivalent to 1 minus cosine of 2x over 2. And raising 1/2 sine of 2x raised to the power of 2, raising this to the power of 2, that would give us 1/4 sine squared of 2x dx. So we can put the coefficient outside the integral sign, the constant, that would give us 1 over 8. 4 times 2, that's 8. And then we can distribute sine squared x to each of the two terms here, which gives us sine squared of 2x minus sine squared of 2x cosine 2x dx. So as you can see, we have two terms to integrate here. Sine squared 2x is not integrable, so we still have to reduce this using, you have to reduce the exponent using the power reducing identity. But here, since we already have a function whose exponent is 1, then we can use integration by simple substitution. So we're going to write this as two integrals. That's 1 over 8 integral of sine squared 2x dx minus 1 over 8 integral of sine squared of 2x cosine of 2x dx. So this time we perform substitution. We let u equals sine 2x. So du equals 2 cosine of 2x dx. So rewriting our integral, that would give us 1 over 8. And then we reduce this. We reduce the exponent. We write that as 1 minus cosine of 4x over 2 dx minus 1 over 8 integral of, that's u squared du over 2. So we have 1 over 16 multiplying the two denominators. That's 1 minus cosine of 4x dx minus 1 over 16 integral of u squared du. So we can now evaluate the integral. That's 1 over 16 times x minus 1 over 4 sine of 4x minus 1 over 16 times u cubed over 3, and then forget the plus c. So our answer is 1 over 16x minus 1 over 64 sine of 4x minus 1 over 48. Our u is sine of 2x, so that's sine cube of 2x, and then the plus c.